Welcome, everyone. Today we're diving into a fascinating discussion on two speech synthesis paradigms. One using latent diffusion with continuous vectors, and the other employing a mixture of experts with lightning attention.
Yep,
They really couldn't be more different, right?
absolutely. What catches my eye immediately is that the current draft just presents Natural Speech 2's continuous vectors alongside MiniMax's MOE features like an inventory list, without explaining why those choices actually matter.
Exactly. It's like just putting features side by side without, a clear comparative framework. What's really needed is an explicit side-by-side comparison of the generation paradigms. You've got latent diffusion on one side and MOE with hybrid or lightning attention on the other. That way, readers can truly grasp the underlying engineering, right?
Right. And speaking of engineering, Natural Speech 2's approach, for instance, uses a neural audio codec with residual vector quantizers, RVQ, which is key because it avoids the long, discrete token sequences that bog down older models.
Yep. With traditional autoregressive systems like VLE predicting tokens left to right, one misstep leads to a cascade of errors. It's, like walking across a wet stone bridge where one slip throws off your entire balance.
Exactly. I love that analogy. Now, Natural Speech 2's continuous vector diffusion is, in a way, more like a painter smoothly blending colors on a single canvas, entirely avoiding those stuttering steps.
Sure does. Although I can see someone might argue that the painter analogy is a bit too abstract for technical readers.
True.
But blending art with tech does help visualize these benefits.
On the other hand, we have MiniMax's MOE approach. It's engineered like a highly organized factory floor, where specialized experts handle data using lightning attention, which, by the way, is a clever twist on standard attention mechanisms.
Right. Instead of the quadratic scaling where every token looks at every other token and, burns through VRAM, lightning attention reimagines it by applying right-to-left cumulative sums. So, it brings it to, linear scaling enabling massive, like 1 million token context windows.
Exactly. And that's a breakthrough for handling multimodal input, text, video, speech, and even music all in one go. It's almost as if MiniMax is built for real-time, robust enterprise applications.
Absolutely. But let's talk about the voice learning aspect. Natural Speech 2 uses a prior model, a phoneme encoder plus duration and pitch predictors that learn from a crisp 3-second prompt. That's smart because it sidesteps the clunky nature of autoregressive token predictions.
Yeah. In contrast, MiniMax employs something called Fluent LoRa. It's designed to separate a speaker's timbre from the actual words using around 10 seconds of, well, even slightly imperfect audio.
Right. It's almost like an advanced vocal equalizer, using low-rank adaptation to isolate the unique acoustic aspects of a voice, such as throat shape or chest resonance, kind of stripping down the voice to its pure mathematical essence.
Exactly. That said, don't you think the draft could benefit from a deeper dive into exactly how Fluent LoRa achieves that separation? It feels a bit too vague when it comes to the inner mechanics.
I totally get that. A detailed explanation would help the readers understand why Fluent LoRa is such a robust solution compared to traditional methods. The more clearly the mechanics are explained, the stronger the argument becomes.
Right on. Now, shifting gears to performance metrics. The document highlights that MiniMax achieves sub-250 millisecond latency, which is vital for natural human turn-taking, while Natural Speech 2 shows zero-shot similarity and a 0% error rate on those really challenging sentences.
Exactly. Imagine a conversation where any delay over 250 milliseconds ruins the flow. It's like an awkward walkie-talkie delay. That's why MiniMax really grabs attention there. But Natural Speech 2's ability to handle tongue twisters, rare vocabulary, and heteronyms in complex sentences is equally impressive.
Speaking of tongue twisters, these hard sentences are purposely engineered with nested clauses and heteronyms to break traditional models. Natural Speech 2 uses non-autoregressive refinement to consistently nail them.
Exactly. It's like it refines the whole sequence, sidestepping that infamous error propagation. You could say that natural speech too turns what would have been an intractable cascade of errors into a smooth, painting-like flow.
Yep. However, one must consider that, in creative industries, fidelity sometimes trumps speed. Natural speech 2's zero-shot singing synthesis, for instance, is not constrained by latency at all, but by quality. Synthesizing singing from a basic spoken prompt is a whole other ballgame.
Exactly. It's like comparing a high-speed race car built for quick turns to a luxury sedan that's all about a smooth ride. One excels in rapid-fire conversation, while the other delivers high-fidelity performance for creative tasks like, international film dubbing.
Right. And that's where the document should ideally delineate use cases. MiniMax becomes the go-to for real-time applications and enterprise integration, while Natural Speech 2 caters to offline, high-fidelity tasks such as voice conversion and even custom singing synthesis.
Precisely. Grounding this with real-world examples, say deploying MiniMax through vendor-agnostic orchestration platforms like Famula, which integrates with systems like Shopify and Zendesk, would really drive the point home.
Absolutely. Yep. Plus, tying in a discussion on the dual revenue model, where consumer apps generate massive conversational data that refine enterprise APIs, shows the practical business side impact of these technical choices.
Exactly right. And these clear, actionable recommendations, from reworking the architectural comparison to framing performance metrics around specific operational bottlenecks, turn an academic subject into a very practical roadmap for developers.
Right. So to sum it up, we have three main takeaways. First, explicitly contrasting the paradigms of latent diffusion versus MOE. Second, synthesizing performance metrics in terms of latency versus fidelity. And third, anchoring usage recommendations with concrete, real-world integration examples.
Exactly. And by doing so, we bridge the gap between theoretical capabilities and practical deployment strategies. It's all about making the technical passion accessible and actionable.
Right. I'm excited to see how these revisions ultimately empower developers to choose the right model for their specific application, whether it's a high-speed call center bot or a high-fidelity restoration for historical audio.
Indeed. It's all about pushing the boundaries of speech synthesis by combining deep technical insights with creative, practical applications. Thanks for this rich discussion, and let's keep the momentum going as this field evolves.
Absolutely. Thanks for tuning in, everyone. Until next time, keep breaking down those paradigms and rethinking what is possible with speech synthesis.